locally, and we're good to go. Before we begin, do we have any questions about the project, workshop, anything you want to know? Any questions? Okay, Bantai and Aaron, okay. So, all right. So let's start with kind of review what we have done last time. Um, when we talked about templates, and we said templates are essentially, um, I see some stuff are blinking on a screen. What's going on here? Oh, no, no, that was this, the size, doesn't matter. Okay, so yeah, as I was saying, we started talking about templates, and we said templates are true uh, uh, face of polymorphism when we are dealing with, when we are concerning polymorphism in C++. And we said we essentially write what we want the compiler to do, and the compiler on demand looks at how we actually invoke that function that we have written, and accordingly it will create the function for us, assuming that uh, what the function needs to actually run is accommodated by the types that the template has. So in here, when we created the sum function over here, saying sum returns a type and receives a type by value and another type by value, then it applies the plus operator between the two and returns the outcome by value. It means any sum that I'm calling over here, the value, the types passed over there must accommodate those things so the compiler can actually run that, which means in here when I go O is equal to sum M and N are type mark, then mark sum, mark A, mark B, which means mark must be able to pass stuff by value, mark must know what plus sign, plus operator, binary operator does, and when it returns something by value, everything is going to work like a charm. And also mark must be able to do assignment operation and all the good stuff. That's how the compiler writes it and creates new functions for every and each. The beauty about this thing is that if you do not use specific version or whatever you need of sum, that function will never get created. Your executable will not have a sum that actually contains those values, contains those logic, the logic that you have. If I comment right now the sum that I have for mark and container, then the sum will only get created over here for integer and double and nothing else. And even if I comment those, then no sum function will get created in my executable because it has never been invoked. Do we understand this? Please stop me at any moment if you think there's some question that you need to talk about. Lily, go ahead. Lily, are we good?
I actually have a question though
Go
anyway.
ahead, go ahead, go ahead.
When I was reading over the notes, I understand the reason for that specific function to support the operator plus overload,
Mm-hmm.
but why does it say copying? Wouldn't it be the copy assignment operator?
So when your type is receiving something by value, so let me just uncomment this one. If you recall when I said when a function is called, this is what happens. So essentially when sum is created by the compiler, you're going to have something like this in here, right? You're going to have mark, sum, and then you're going to have mark A and mark B, correct?
Yes.
And when it's called, it becomes A equals M and B sets to N. This is how the function is called, correct?
Ah, yes, yes.
So assignment at the moment of creation is a call to a one argument constructor. Therefore, A has to be a copy of M, and that's copy constructor.
Okay, thank you.
All right. And thank you very much for the question. All right. So we are good down to this point, hopefully, everyone. Are we okay with down to this point? Especially Lily. You said no, you're not okay. I want to know if you're okay now. Or it was just a misclick. Are you okay? She said okay, so I'm a happy boy. Okay. Um, all right. So the next thing we need to talk about over here is that what if, for example, container over here did not have the plus sign up overloaded? What if our container was like this? And instead it had something like, let's say, int data const that returned the data. Return, seriously? Return, there you go, data. So if I wanted to work with, now if I actually compile and run this, it's not going to work anymore because now it's going to tell me, hey, what are you doing? You are saying the type container over here doesn't have the plus that you want to use. So whenever you see a message like this with templates coming up, it actually screaming what the heck is going on. Wow, look at the number of error messages over here. You see binary plus type doesn't define this operator or a conversion to a type acceptable, yada yada yada. So it says it doesn't work. So what are we choice like? How can I fix this? I want sum to work, this sum to work with container. We mentioned that overload always supersedes templates. So if I actually, what did I, container. So if I actually write over here something like container sum, container A, container B, and in here I would say return container A dot data plus B dot data. So what I'm doing in here is essentially saying that when the I'm writing a sum and I'm going to say sum container A and B. So create a nameless container, and what you are creating a container with is the data of A plus data of B. Therefore, I accomplished the sum. Now, if I run the program, you will see that because the overloading always supersedes the the template definition of that one, compiler says, no worries, I'm going to use this one instead of that one. Are we okay with this? Danny, are we good? All right. So now this is good. This is okay. So this is one of those things that makes our code work, but it kind of ignores what we have template here for. Template here is here. So if I do not use the function, I do not want the binary to get created. So if I do something like this right now, if I actually do something like this, and I do not use the sum for the container, my question is, will the compiler uh, generate the code for the sum? Will the compiler generate the code for the sum working with container? Now, this is an important question. I want to see if we understand what's going on. So if I send you this, like, will the compiler, when I'm not using the sum, when I'm not calling the sum function, will the compiler generate the code for the sum working with container? And I want you to think about it. Two people so far answered, one right and one wrong. So what the template does is that the template says, I'm going to write the code for you if you actually use it. A function says, I'm going to write the code for you no matter what. Now, knowing that, do you think the code is actually generated for this one or not? Kevin and Danny are thinking, I guess. Okay, so just to show you the result at how important it is to understand, 36% of us is incorrect because they said, no, it's not going to create. Yes, it will create it. This is a regular function. A regular function will be compiled by compiler. A regular function will be compiled by compiler no matter what you do. It doesn't need to be called to get created because you wrote it. It is final. Compiler knows what it is. It creates it. A template function will not get generated by the compiler unless it is called. And it is called 3 times. So this template will generate 3 functions. That is one some for integer, one for double, and one for mark. But if I remove one of them, then it's not going to get created. However, this function is a finite function. It's a function that is created, and it is a final function. It is created, implemented, compiler knows what the code is for it, and it's going to compile it no matter what. Now, knowing this fact, will the compiler generate the code for the sum working with container no matter what? Still, people have doubt. Soyun, go ahead.
Yeah, so as I understand, if we don't have from line 49 to line 51, and you don't call the sum function for the type container, then the container sum never get created because nobody
Correct.
asked to do it.
Exactly.
But yeah, but if we have the 3 lines of it, so you already write it, so the compiler anyway creates it no matter what.
So compiler creates the sum for integer, double, and mark, but not for container.
So the
No,
normal function is always existing.
always exactly. So if I
Yeah.
have 50 of these things, my code is going to be 50 times bigger no matter what I do. It is always there.
However, template gets create function on demand. Am I right?
Exactly.
Okay, okay,
Exactly.
got
So
it.
it's
Thank
for
you.
those 2 people who said no, just listen to what Soyun Lee said right now. Okay? So the template only gets created if it's used. Regular functions are always created no matter what. Which brings us back, which brings us to the point of so what do we need to do? So what if I do not want this thing to get created? What can I do? Okay, so what if I want this to be a template too? Obviously, I can't because it doesn't have the plus operator overloaded. So it's not the same logic. What can I do to make this function to be a specialized version of this sum? So I tell to compiler, if sum is called in any way, use this one. But if it's a container, use it like this. You can do that by actually creating a template over here, and don't put anything in here. And in front of the sum, you mention container, which means now this function is a template too, but only if sum is used with a container. And now you can bring this up. So now if I actually remove this and take it off, the function sum will not get generated for it because it's not called. So remember, this is called specialization. Okay, so function template specialization. Okay, so this function template specialization gives you the chance to have a different logic using the same function and still make it a template. Do we understand this? Are we okay with this? And that's the syntax for it. So all you need to do is to have the same name, create the function the way you want to, but add the signature of the function in front of the sum function. So we know how it's done. All right. Uh, that's one thing. So that's function. And by the way, this is not in your. If, I thought it was actually. I went through all the notes, but I didn't see this because it wasn't there. So um, um, take a look at the notes, see if it's there. If I find out that it's actually been mentioned in OOP244 notes, then it's going to be in your question. Otherwise, this is a 345 matter. Are we okay with this? Okay, so that's functional specialization. Um, ABC func template specialization.cpp. Another thing I wanted to mention over here is that how can we explicitly call something call a function template. Let me just have it like this. So let's say I have the double thingy over here. So obviously if I, sorry, why is it compiling? Yes, go ahead. Yes, go ahead.
Yes, can I ask that about the type and the container? What if we in the container we have the add operators plus operators for this? Is it work for the sum template?
If it has the plus operator, then yes, you don't need to do it.
Oh yeah, yeah.
So
That's what I what I'm thinking about as well.
yeah, so
Yeah.
that's the thing. So the reason I did that, that I removed the operator to create that scenario.
Oh yeah.
You
Thank
have a
you.
class that you want the sum to work for it, but it doesn't have the plus operator. Therefore, you have to specialize it.
Yeah.
Therefore, you have to say over here template like that and say this is just for the container and nothing else. Okay?
Oh, yeah. Thank you.
All right. Now, if I call the sum like this, what happens? You know that it is going to actually print 3.3 over here. Okay? But what if I want to call the sum that is created for an integer and pass x and y? So it casts the x to a double, to an integer, and y to a double. You can do specific call manually to a template by telling to the compiler, I want the integer version of this thing to get created. So you can override the automatic creation of the compiler by telling the compiler which one to create. And when you run this program, you're going to get only a 3 over there, as you see. So essentially, it creates uh, the the template for an integer and passes the double to it. Uh, so you will get warnings like this, which is very fine. But so essentially, it's saying you're converting a double type to an integer. You're going to lose data. We know I did that on purpose and I want it to happen. So you can manually, if you see, for example, you have a sum that is doing a double and an integer, and you want to call the sum for an integer for this one to make sure that the argument is being passed specifically, you can request creation of a specific type. So this one manually asks the compiler to create the integer version of sum, even though double is passed. Do we understand this? Are we okay with this? All right. So that's that. So that's uh, I'm gonna call it CD, manually request a func template call. Okay, so in here you are actually doing that, and now we know it. So this was the function template specialization. Okay, and save, and come back over here. All right, so now what I want to do is to have a very quick review on dynamic memory allocation and things that we have done. So together we're going to create, I have a question. Did I create a dynamic integer array in this class by any chance? Do you remember me doing that, creating a dynamic integer array class? Okay, good. One person said yes. Who said yes? I just want to know if I did it so I can bring the code. Let me just search for the code if we have. I doubt that I have created something in this class, but I'm going to search anywhere. Anyway, so dynamic or an integer array. Let me just see. No, I did not create it. I did not create it. Oh, sorry, I pushed the wrong thing. My apologies. All right, are we okay now? You should be able to see the screen. Yeah. So what I'm gonna do now, I'm gonna quickly create uh, an integer array class that is dynamic, and it's gonna review on dynamic memory allocation and everything. So be with me and listen to it, and if you have any questions, let me know. Uh, and Daniela and Jay Lee are connected. Listen only. If you have a microphone, please reconnect with your microphone. I do not like people connecting with listen only unless you have to. So that's that. All right. So an integer array. So I want to create because the integer array that we had in uh, C, the arrays that we have in C language are not sufficient and they don't work properly because they don't know what their size is, and you can go past through their size and it causes trouble and stuff like that. I want to create an int array to replace the integer arrays that we have in C language. So this is my int array class, and obviously I'm going to create uh, the safeguards for it. And in here we're going to have end if and close the stds. So I have my integer array, and then I'm going to go to int array.cpp. In here I'm going to say namespace stds and start working on the integer array. So the purpose, the goal of what I want, the goal of this program that I'm about to write is to create an array of integers that can, let me just minimize this one, minimize this one. We don't need these now. I can let them be. So what I want to have is something like this. I want to be able to say int array, say a 5, and I want to be able to have an array of 5 integers. And I want this array to be intelligent. I want to make sure if I go A10 is set to 32, something like that. I don't want it to crash. I want A to know that the size that it is not sufficient and automatically resizes itself, make itself big, and creates the space so it's going to become 10 integers, 11 integers in this case, and put the 32 over there. So do we understand what I want to do? I want my array to, and I want to be able to know what the size of the array is. I want to be able to say cout a dot size, and I want that to actually tell me what the size is, so I know what's going on. So I can actually pass the array to a function without passing its size, and I want it to work nicely and beautifully with no memory leak. Do we understand what we want to do? Are we okay with this? So let's go to the int array and see what we want to do. So the very first thing that I need to do over here is to actually create an array. And I know that the arrays are nothing but a pointer pointing to series of stuff. So I'm just going to have this one and set it to null. This automatic stuff that they have done to the language. Anyways, yes, setting the data to null at the beginning. And obviously, when I am creating this, I want to make sure that I have the size of the array, and that's going to be the size. So m size will be the size, and size t is essentially an unsigned integer. It's a type in C++ that is used to keep the size of stuff. Okay. So the next thing I need to do is to create the constructor for this to actually create the array. So I'm going to have the int array constructor created. And the int array constructor for me receives a size t size, and I'm going to set that one to 1. So if they don't mention what is the size, it's going to be an array of 1 element. Then I'm going to create all the good things that it needs for rule of 3, which is copy constructor, copy assignment, and the destructor. So int array destructor is the one that I'm going to create, and obviously we'll make it virtual because that's what we said. Everything has to be virtual, every constructor. I am going to overload an operator equal to make sure that I can set the integer array of mine to a legacy array. So what happens is that, for example, in here, if I have an array of, let's say, integer AR3 is set to 1, 2, 3. I want to be able to say A is set to AR, and I want elements 0, 1, 2 to be set to 1, 2, and 3. So I want to make that happen. And for that, I need to overload the operator that accepts a constant integer array as a right-hand operator. Obviously, because the arrays that are being used sometimes we don't know that if they are smaller or not. We want to make sure it goes up to only certain size of it. So if this is 30, I want it to be only the first 5 of them to get copied. For that, I simply create another function to set the array to an integer with an array size. So that's that. So these are for legacy arrays. So the good old arrays that I have that in C, I can convert it to this one. It is extremely important for me to know what is the size of the array. Therefore, I'm going to have a method called size_t to return the size of the array. And obviously it's not changing anything in the function in the array. I need to know if the integer array is empty or not. So I'm gonna create a Boolean operator that tells me if it's in a valid state or not, so I can see if I can use the array or not. The array needs to resize itself. So I don't know if I'm going to put this thing in a private section or a public section, but I'm going to put it anyway. So I will have a void resize that gets the uh, the new size over here. So let's call it new size. And with this resize, it's going to resize the array, either make it big or make it small. Uh, like you have an array of 5,000, now you want it to be 500, you can resize it and make it small. So yeah, so it's a good idea for this thing to be uh, uh, um, um, a public one. And we don't waste anything in here. I'm not going to return a void. I'm going to return actually an int array reference, so it can be reused later on for stuff, other stuff if they want to use it. Uh, Finally, to make this thing actually an array, I need to give access, controlled access to the element of the array, and we know that it can be done with the index operator, which is going to be as something like this. So here is going to be size t index. So essentially I pass the index to size t to the index operator, and it's going to check to see if the index is within the acceptable size. If that's the case, it returns the reference of the dynamic array, and if size is not satisfactory, it's going to resize it to make it proper. Also, I need to have a read-only operator of the same version created in case somebody wants to access a constant integer array. If that's the case, the operator should not be able to change the array. So I need to overload this by actually creating a constant version of the operator, which receives it as follows. So size t index const. So what happens is that if a constant reference or pointer of integer array is passed anywhere, the operator index that is constant will be called, and will make our life easy. So this is what we want to create, and this becomes a dynamic array that I can use anywhere I want, like a regular array. Are we okay with this? Daniela, are we good? Any place that you think I'm talking about something that doesn't make sense, stop me, activate your microphone, and talk to me. So I want to be quick. So what I will do, I'm going to quickly create all these definitions. So that's one. And that's two. So I'm going to create the definitions one by one um, to just fill in the blanks. I don't want to waste time writing the signatures for them. So I'm just generating the functions, and then I'm going to go one by one create it. That's the size and operator bool, resize, index operator, and index constant instant operator. So now I have all of them. I'm going to save it, split the window, and we're going to go about creating the the um, the integer array class of ours. Now, before doing this, I want you to go have a glass of water, I don't know, renew your coffee or something, come back 5 minutes, and we're going to go through this, create this very quickly, and then we're going to get into class templates and see how class templates are done. So 5 minutes. Are we okay? 5 minutes? Are we okay with 5 minutes or more? Or you want to make it 10? Five is good? 5 is good. All right, 5 is good. See you in 5 minutes. I'm going to pause the recording. Please remind me to continue recording afterwards. Thank you. Before we continue, any questions before we start coding this thing quickly? Are we okay? Let's put it this way. Are we okay? Can we start? Are we okay? All right, so what are we going to do? Let's take a look at the code and see where we stand. So first of all, I want to create uh, the uh, integer array. So what I need to do over here is simply set the m size to the size that is coming through. So that's what I need to do. And then after that, I simply make sure if the size is 0, I'm going to make that size 1. So I'm actually borrowing the code. It's already written over there. I'm not going to dump everything over here. I'm going to go one by one and explain. So uh, I'm setting the size to whatever it is. If the size is 0, I'm going to set it to 1. So the array cannot get created without uh, let's put yeah. So the array cannot get created empty. So it's impossible for m data to actually be completely uh, empty. It has at least one thing in there, um, which probably eliminates the need for the Boolean operator anymore because we'll go through it and we'll see. Anyways, so that's that. The next thing is to instantiate, to copy the array. And to copy the array, what I will do is this. So the copying the array, I'm going to set the m size to the size that is coming it from the array. So this is the one. And then I'm going to allocate enough memory to the size of the other array. One by one, I'm going to copy everything over there, and the copying is done. Um, what is this thing saying? Variable yada yada size t is uninitialized. It is not uninitialized. It is initial. Oh, yes, it is not. It's initial. My apologies. See, good. That's the good thing. It actually mentioned it to me. There we go. Now that it's initialized and we're good. All right. So that's that. All right. For operator equal, essentially, I have to make sure that it is not a self copy, and then I'll do the copying as I've done with the other one, which takes me through standard procedure for it. So if I do not, this if I thingy invokes the Boolean over here. We'll see if it's needed later on. If not, we'll remove it. So if this is a valid thing to copy, and if I am not the same as the one that is being copied, then I'm going to delete the current data, and the same procedure happens exactly like the other one and gets copied. You can later on uh, um, organize it and make it better yeah, as you see over there at the top. So let me see. This is data. Yeah, so in here, what it's doing, this is actually invoking the I2. So essentially, it says if this is a valid, if the M data was actually allocated properly, and the data, uh, uh, the data is not null, which means the data of the function that is coming in, and then the size, so on and so forth. So it essentially uh, makes sure that everything is good when the copying is happening. And in here for the assignment operator, it does the same thing. So if it is valid, and if it is not the same thing, and if it's not the same object, then the copying is going to happen as it goes. So one by one, everything is copied, and the size is copied and returns the current index. And that's that. Are we okay down to this point? All right, the destructor is the breeziest one over here. So all I need to do is to delete uh, the m data, and that cleans up my that cleans up my uh, dynamic memory allocation. For the assignment equal, all I need to do is to one by one go through the array that I have over here. Now I'm calling this array. That's a little tricky because uh, there is something in C++ called array. So I'm going to change the name of that. So in here, I'm going to do it afterwards. But we have actually an object called array in C++. That's why it kind of gets confused, but I'll fix that afterwards. So it is copying a legacy array right now, going through it one by one up to the size of the current array and copies everything. So it assumes that the legacy array has elements to the size or bigger than size of the array of our arrays, and it's going up to that point. The If it is if I am going to uh, put the integer, or if I am going to set my array exactly to an array with a specific size, then what I need to do is first resize the array to the size. So whatever the array size is, I'm going to set it to that one. And then after it is set, I am going to say return this equal to array. So what happens is that first it resizes and adjusts the size to the legacy array, and then it's gonna call the previous thing that we created and return it, and so on and so forth. Are we okay with that set? All right, so um, the Boolean operator thingy over here that we have, it simply returns if the mdata is not null. So I'm going to say return mdata not equal to null ptr. That tells us that the array is actually valid and it has something in it. In case anything goes wrong with it and the data becomes null, that can be tested. How do we resize? So to resize, the very first thing that I have to make sure is that the new size that is coming in is not 0. So I have to say if the most important thing is to see if the size is different with what I have. So if the new size is not equal the size of me, then do all these things. Other than that, just return this. I'm done. So I don't need to do anything. If the sizes are equal, then what am I doing? I don't need to do. But if the sizes are not equal, now I have to check to see if the new size that is coming in is actually not equal. If it is equal to 0, then I have to set it to 1, because that's our business logic over here, having minimum size of 1. And then after that, we're going to do a copy of, we're going to first create a temporary pointer, and let me just bring it over here and explain. So first I'm going to create a new integer with the new size that we have. So the temporary will actually have the new size. Then I'm going to start from size t0, and if the temp is not null and mdata is not null and I is less than new size and I is less than the size of this function, this class. So it has to be both, whichever comes first. It copies everything one by one from one to another. Then it deletes the current data, assumes the new memory that is just copied into, and updates the size, and the array is resized. Are we okay with this? Now the two arrays that we have over here, this one is the easiest one, so I'm going to create. It's 2 seconds. So in here I'm going to say return mdata index, but not mdata index. I'm gonna make sure that it stays within the boundary, and we know the trick for that. So I'm gonna put over here mod, and in here I'm gonna put m size. So whatever my size is, give me the index mod that one. So if index passes or becomes equal to m size, it loops back and it remains in the same place. So this will give access, if it's constant, to the elements, but only the elements, and it won't go off the boundary. Are we okay with this? All right. Now, let's talk about this one. This is not actually very difficult. In here, I'm going to say if the index that I am receiving over here, if the index I am receiving over here is greater than or equal to m size, then that's the time that's the moment that I have to actually resize it. So I'm going to say resize to index plus 1, essentially make it 1 bigger. And now that it's bigger, I can comfortably return m data index. So what happens is that if the index is out of bound, it's going to resize to its size and return it. Otherwise, it's just going to return the reference of the current object. And ladies and gentlemen, now I have an integer array that is dynamic and can work with whatever I want. So in here, I'm saying int array. What is this? Oh, I have to include it. So I'm going to say include int array dot h. Now, and we are in stds, so let's just walk through exactly what we have over here. And in here I'm going to say for integer I set to 0, I less than a dot size and I plus plus. And in here I'm going to say cout. Actually, let's not do that. I'm going to say void prn array, and I'm going to get a constant int array in here, and called I, reference I, and in here I'm just going to simply say cout. Now in here I'm going to say for I equals 0, integer I set to 0, I less than the size of the array, and I plus plus, and then I'm going to say return, not return, sorry, cout I, the element of the array, and print a space, and after that I'm going to say return, or let's make it comma separated, that's better. So I'm going to do it like this. So I'm going to say print this, and then if I is not equal to size minus 1, cout comma. So it's going to make it comma separated, and that's I size. And in here I'm going to say cout and L. And first let's run the program. If it runs properly, if it compiles and runs, then I'm going to walk through it. There we go. Okay, so actually I have to write over here prn array A. I got a 0 over there. Something was fishy. Let's go through it and see why we got 0 in here. Where is my a dot size? A dot size. Oh, return size. Return m size, not size t. M size. Sorry, I forgot. That's why it returned 0 over there. Okay, so let's run through it and see what happens. Oh, before we begin, are we okay? Anybody have any question? If you have a question, ask or tell me if you're okay or not. All right. Okay, so I'm gonna create this one. So integer, it's gonna create an array of 5 integers, as you see, sets everything to null and creates an array of 5 integers and comes out. Now I'm gonna say a10 is equal to 32. So there is no 10. I'm gonna say a10, so it comes up right over here, and it says I want to set the index 10. Index 10 is bigger than that. It goes resizes the array to the new size, which is 11, obviously, adding 1 to it, and copy everything one by one from the other side to here, including garbage and everything. Delete the original, assume the new memory, resize it, and get out. And then it comes
I
back
have
out.
a
Yes,
quick question.
go
I'm so
ahead.
sorry.
Go ahead.
In your for loop in the resize,
Hmm.
why do you check to see if temp is valid when you're in one of the conditions? Because you already know it's not going to be null PTR.
Oh, yes, it would be if you don't have enough memory.
Oh, I see. Okay.
Okay. All right. Okay, so that's that. Thank you, actually, good question. So now it comes out and it sets it to 32. Now it's going to print what the size is, which essentially would be 11, obviously. And then it's going to set A to AR, which means it's going to set A to the value of AR. And that's going to be actually a disaster over here because this one's size is 11 and that one is 3. So if I do it that way, you'll see actually, let me show it to you. So it's going to put lots of garbage in there. If I actually run this, it comes in here and starts copying up to 11 out of that 3 that we had. So not a good idea. I'm not going to do that. I'm going to change the value like this. It's not wrong. It's just, it's not supposed to be. I could have set it to that one. So I could say a dot set and I could go over here AR3. I could have done this and it reduces the size to 3. But let's make it something better. So in here, I'm going to put 4 and 5 and 6. So I have 6 elements in here. And now in here, I'm going to say AR and 6. So I'm going to do it like this so it actually sets it. Let's come down right to here. And let's print it actually before that. So I'm going to say PRN array A so that it shows what was before. So let's stop over here. Run it one more time. So it comes right down to there and it's 11. So it goes right up to the PRN array and in there it knows the size is 11. It prints the first one that is garbage, garbage, garbage. Oh, why is our garbage? Should be something in here. A 32 and comes out. Yeah, because I didn't put anything in it. So I only had a 32 on 11, on the 11th one, and that was it. So that's why everything was garbage other than that 32. So it actually worked properly. Let's run it one more time. Okay, and now it's going to say set it to AR6, so it goes up right over here and resizes to 6, which means it actually shrinks it. So the size is different. It becomes 6 of them, so it actually copies the first 6. That is all garbage. And then comes back out. Now it's 6. It goes in here, and now it's going to set the array that is 6 to this one. 1, 2, 3, 4, 5, 6 gets copied from the array, goes out, and now it says print it, and one by one it's going to print all the values in the array as you see, and comes out and gets destroyed at the end. Are we okay with this? So that's what we created. And you can use this array any way you want. That's very fine. But the problem over here is that now this is the review of dynamic memory allocation and everything that we had at the beginning. Now I'm going to go back to what we are teaching now, which is an OOP345 thingy. How do we change this array to be an array for everything? Okay, not only integer arrays. I want it to be array of containers and marks and whatever I want. I want this to be an array of anything. How can I do that? To do that, we need to create a class template. Now, how do we create a class template? The very first thing you need to do, as we said before, all the code related to a template should reside in a header file. So what I'm going to do in here, I'm going to actually create a header file over here. I'm going to say add new item, and I'm going to make it a header file, and I'm going to call it dynamic array because it's not an integer anymore. It should be anything. So I'm going to call it dynamic array. So dynamic array.h is the one that I have. Create the safeguards for it. If not defined, stds dynamic array and define it. Very simple and easy. Define and be done with it. Now I'm going to bring everything I have from the integer array in here. So I'm going to bring the namespace and all the good stuff that I have and copy that and put it in dynamic array. There we go. Then I'm going to bring the int array part, which is everything else, in the stds, copy that, and put it in the dynamic array.h right underneath inside the thing. So everything is in the header file now. Now I'm going to change the name of this one to int array main CDE. So that's int array main.cpp. And remove this int array. We don't want it anymore because now now we are having the dynamic array. So remove that, remove. And in this program of mine, we're gonna have dynamic array included. Dynamic array. Now let's actually change it. So first of all, it's not int array anymore, it's dynamic array. I'm going to change all the name over here. I'm going to say exactly match it, and I'm going to call it dynamic array and replace everything. So there we go. Oh, should he change it to current project? Okay. It's okay. I removed those things, so nothing bad happened. So, all right. So it's all changed to dynamic array. And one more thing I had over here that kind of bothered me, that I used the name array here somewhere. So I'm gonna change array to a RR over here, and it's current document, and replace everything. Yeah, just didn't want to have a conflict with what we have in C++, not to make a mistake. So now I have everything set over here. It's dynamic array, and I want to change it to a template for a class. Are we okay down to this point? All right. Now, the problem with class templates is that unlike function templates, they don't have a signature. When I'm saying dynamic array A5 over here, life is beautiful. Okay. Now, obviously this works because it is the integer array. So if I run it, it works perfectly with no problem, exactly as it was before. But that's not what I want to do. I want this thing to actually, let me just put some nice values in there. Instead of doing that, I'm going to take it out over here, and I'm going to say for integer I set to 0, I less than 10, and I plus plus. And in here, I'm going to say, what am I going to say? What am I going to say? What am I going to say? I'm going to say AI set to I plus 100. So I'm just putting some values in there, and I don't need to set it. I'm just going to show the values after we're done. There you go. So now if I run it, it's initially 5 with garbage in it. I keep putting it up to 10, and as you see, it becomes 10 of them, and it shows everything. So we are all set and done. Okay, so that's the thing that I created. Now the problem over here is this. Now I want you to pay attention. Okay, if I write, I want to convert this to a template. So we know that every single scope needs its own template statement. Are we okay with this, to understand that each scope needs the template statement of its own? We remember this, right? All right. So now that we remember this, let's take a look at this. In here, I'm going to say template, and I want it to be any type. So I'm going to say type name, type. Okay, so let's change everything in here. So obviously the int over here has to change to type because I want it to be any type of integer. So that's the type. Then I'll come down over here. This is size, has nothing to do with anything, has nothing to do with anything. Here it is setting it to another legacy array of the same type. So I'm going to call this one type. And it's going to be setting the same thing. So that's going to be type. In here, Boolean, it's got nothing to do with anything. In here, it's returning the element, it has to be type. And in here, it returns an element and it has to be type. Okay, so that's how we did it in a function. Are we okay with this down to this point? All right, so now if I come back to my main, now if I want to come back to now if I want to come back to my main in here, I cannot, there is no way for C language to kind of actually know what is it creating in here. But if you recall, in functions, to manually create something, I could add the signature of the template to the name of the function. Remember that? Are we okay with that? So we can do the same thing for classes, and that's actually how classes are created. So in here, class templates. So in here, instead of saying dynamic array, I can say create a dynamic array of integers for me. And that tells to the compiler that the type you are receiving over here is an integer, and therefore a dynamic array of integer is now created. Hence, any type of dynamic array. Are we okay with this? The problem over here is that if so I create this, fine, it's going through it, okay. But the problem over here is that when I keep creating templates, because I have to add the template over here too, right? Type name, type, and obviously set it to whatever I want to set. The problem over here is that when I have two different ones, so let's say in here I have one as integer I in here. So let's say I have integer, dynamic integer as A, and I create another one as, say, double over here. Let's call it D. And I'm going to do something like this. So it is exactly like that one, but it's a double one. So what I'm going to do in here, I'm going to say plus 1, 2, 3. So that's going to be double. That's going to go into D. And that's D actually. And I'm going to say, tell me what is the size of D. And in here, I'm going to print the D. And let's make this one 20 this time. Or, yeah, 5. So that's not, let's make it 15. Okay. So there you go. Or make this one 15 and make that one 10. Cannot make up my mind, can I? So if I do something like this, ladies and gentlemen, when I say over here, I want an integer, dynamic integer, compiler is going to create two classes for me. One dynamic integer of type array, the other one dynamic integer of type double. Problem over here is that then how does it know that it has to create two of these and which one it belongs to? Because this dynamic array is member of which one? Dynamic array of int or dynamic array of double? Because of that fact, in your implementation, you must add the signature of the template to the name of the classes wherever you see it, with exception of 3. So the type over here that you see must be added to the name of the class so it knows which class you're talking about, with exception of 3. So add the type name of the template to the name of the class, except for very first thing, the name of the class that comes right after template won't catch it. So number 1, the name of the class right after the template statement. So this will not get it. Number 2, names of the constructors. Why? Because they are not really functions. Constructors are not functions. They say how the object's supposed to get created. It's not a method. It's not something that needs a signature. You're just telling how this thing is supposed to get created. Therefore, it doesn't need a signature. And number 3, another special one, the destructor. Destructor. So in this case, following these things, this will not carry the type. This is a constructor name, will not carry the type. This is a constructor name, will not carry the type. But this is not a constructor. It's a reference of dynamic array. I have to say which type of reference. Do we understand this? Are we okay with this? And then we can continue one by one and go. So this one, again, it's a it is a return reference of dynamic array that is being returned. It needs, oops, it needs a signature. This one is again a reference of dynamic. It needs a signature. This is a destructor, does not need anything. Here is a reference. It needs it. That's type, again a reference. It needs it. In here, it's a reference. It needs it, and we are done. So this is done. Now let's come to the functions one by one. Template, type, name, type. The first one is the owner. It's not the constructor, so it needs a reference. The second one is the name of the constructor. It will not get anything. Inside the function, a new array of type is created, so this has to be type. Are we okay with this? All right, so now let's do the copy constructor. So again, template, type name, type. The first dynamic array, it's the owner, it needs it. The second one is the constructor, it doesn't need it. The third one is the reference of dynamic array, it needs it. In here it's creating a new int, so it's new type. And it says unsigned I less than this and that. So actually this unsigned should be size T, not unsigned. Size TI. And data yada 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 goes over there. So it is copying. Everything's good and there's no problem. But just it's a good idea to just keep track of the things that you're doing. For example, when you are doing a type like this, just put a note over here that it needs a default constructor. So because you have to document it, right? You have to mention that this class is a template that does this and that, and the objects and the type over here requires the following. Obviously, the way I see over here, rule of three, there's no question it needs to have it. So I'm just putting rule of three, but the default constructor is the one, and you will see. So in here it's the assignment, which means it is copy assignment. All right. So then I'm going to add the template over here, type name type, and again, reference needs it, owner needs it, reference needs it. It creates a new type of array, and it's somehow giving template. There we go. Okay, it's new type, and everything else seems to be fine. In here, the destructor, template, type name, type. That's the owner needs it. The destructor was one of the three. We should not put anything for it. Are we okay with this?
Corda, can you go up to line 23, please?
Yes, of course.
23. Should that be a type as well?
Yes, it is, and I forgot. And dynamic array, I don't know what the devil is that. So that's that. Thank you. How did you see that? It was up there. You remember it from
I was holding on to it until you said, "Are you okay with this?"
Oh, okay. All right. Thank you. Well, thank you very much. But perfect. Yes, exactly. That's what it's supposed to be. Thank you. You know what? 2% for the final. Because you're paying attention. Okay, so.
Okay, then can you go to line 54 and make that size T as well? Because you did the other.
Yeah, I
loop
know,
as
I know,
size
I
T.
know. For that, I'm not going to give you 2%, but. All right, so this is good. Yeah, because I changed everything. For the other class, I did unsigned int. Then I saw since this is a 345, why don't I introduce size T? So size T is for size. So anyways, so template again, type name, type, and it was Kevin, right? It was
Yeah.
Kevin. Yeah. So Kevin, stop me. Don't wait for anything. Just stop me.
Okay.
So also I'll fix it. Anyway, so that's a type, and this is an owner type. This is copying an integer array, so that's a type. And this is size t. That's good. Everything else seems to be okay. We are very close to finishing it. Template, bear with me. Template, template, type name, type. So this one is going to be dynamic array. It's an owner, so it's going to be that one. This is an owner again. It needs it. This is copying a type. That is that. Resize set. Everything's good. In here, there is another template. Type name, type. And it's the owner of it. It returns the size, so there's nothing over there to change. Template, type name, type. And this is another one, the owner, and we're good. Resize template. This is the one that we have to pay attention to. Type. So the owner and the reference are fine, but we are coming over here. It's resizing, so it is a type pointer temp that creates a new type over here. And size t and everything looks good. Everything else appears to be fine. And finally, template, type name, type. And I'm going to have a type return because it is the type that is being returned. Obviously, it's the element. It has the type. And everything seems to be okay. And last but not least, template, type name, template, type name, type. Obviously, it returns a constant type reference, and it belongs to the dynamic array of type, index. Everything else is good. If I did not make any mistake, now, ladies and gentlemen, we have ourselves a dynamic array. But because we had a function over here that printed the array, you have to fix that too. So I'm going to convert that one to a template too. So in here, template type name type, and this is and a dynamic array of type, and everything else I think is fine. And we are ready to go. So now I have an integer and a double, and let's run it and see if we're going to have two different ones. So let's compile and run. I'm just going to first run it, see if it works, and voila! The first one has 15 integers, the second one has 10 doubles in them, and they're both perfectly working. So now I have two dynamic arrays, one for an integer, one for a double. We could have put marks in there if you want to. It doesn't make any difference. They're all working perfectly as we see it. So let me actually see. I want to see what the mark has in here. So mark can get printed. It has a constructor that accepts an integer. So take a look. I'm going to actually create a mark of it too. So I'm going to say dynamic array, dynamic. In here, I'm going to call it mark. And I'm going to say M5. And I'm going to do the exact same thing. So in here, I'm going to let's actually do something even better. So in here, I'm going to say mark. So this is a regular array mark, 5 of them, and mark MA, and I'm going to set it to 50, 60, 70, 80, and 90. So there are 5 marks. Obviously, because mark has a constructor that accepts an integer, automatically this is going to call the one argument constructor of mark and create the mark with those data. That's what we know. So now in here, I'm going to come and say M is equal to MA. So everything that we designed for that should call and run properly. And then I'm going to do it like this. So I'm going to say print, actually we don't need that one. I'm just going to print everything for it. So I'm going to say m.size. So what is the m? And print the m array. And hopefully if everything's okay, we will see that we're going to have an array of marks. I don't know how we forgot how to create it, but we'll see. There we go. So I have mark 50, mark 60, and as you see, an array of marks are created. Are we okay with this? All right, so now you have actually a dynamic array. This is actually a good class. You can actually use it for anything you want, and it works like an array, and you can it it has everything that an array has. So anyways, you can use it. Add it to your utils thingy, and um, it's a dynamic array. Any questions, people? Questions? All right. So that's that. Please go through this again. What I want you to do, like if you could really do me this favor, I know you're not going to study this for final because we don't have this one. We don't have class templates in final. But what I want you to, but we have a small one. You take a look at that array thingy that it is in the notes. Look at it yourself and you'll see exactly what I'm talking about. So um, uh, um, what I'm saying is that um, look at my integer array and do what I did yourself. Convert it to a template without looking at the template that I created. See if you can do it. If you can convert that one to a template, then you're off. You know exactly what's going on. And from now on, whenever you want a class template, you create the template with a normal primitive type. And after you're done, you simply change those primitive types to a template type, and you have yourself a class template to create anything you want out of it. As simple and easy as that. Questions? Anyone? Lily's not responding to me for some reason. I don't know why. I'm not getting her. Uh, oh, there we go. She heard me. All right, so that's that. If there's no questions, please review this, and it's going to be a good one. This is the lecture for today. Have yourself a wonderful and beautiful day, and I hope everything's going to go fantastic. Bye bye, everyone, and um, I will send the code review requests. I'm going to open up my schedule and starting from tomorrow, start booking appointment. Whoever receives an email from me, please start booking an appointment. Or I may, you know what I'm going to do? I'm going to probably create nah, people are going to leave it for last. So I'll send you requests. So you're going to receive emails from me to book an appointment. I'm going to create a video because lots of people don't know how to do 20 minutes. So I'm going to set the 20 minutes to tell you how to do it. Remember, you have to manually go into the scheduling assistant and actually manually type the time, not to use a drop down. So because it goes by chunks of 15, so you have to do it like that. And I'll send you the details in the email. Have a beautiful day, and I'll see you soon. Bye, everyone.